Yeah, I am somebody who likes to build things, like build um, meaningful systems, interfaces, inventions. And what I really love is connecting the physical world with the digital world. And if you see, like, I mean, we are interacting through a computer right now, which is in the digital space, but the computer itself is a physical object. And if you see so many interesting problems around us, the problems that fascinate me, they exist in the real world. And I think most of us who spend the day, if you look around yourself, there are so many amazing things happening, so many problems that you see that can become a source of inspiration for building something that can solve somebody's problem and eventually become a cool idea, an art project, or maybe a business someday in the future. So I'm not going to keep talking. I think I'll show a few examples of things that I have built throughout my journey, why I built them, the mistakes I made, and how they became from a napkin sketch idea to something that people use. So I'm going to quickly share my screen, and if you can confirm, you can see it. Or can you see my screen now?
Oh, it actually ended, so you might have to start again now.
Okay, just a second.
Yep, we see it now.
Okay. You can see my screen. Right. So I'll just quickly give a background. So, I mean, I was during my first internship right after college, right after my undergrad, I was studying normal computer engineering. Most of us do that in India. And while doing that, while doing my first internship, I used to live in Bangalore. Like there's a big city down south. And on my commute to office, I used to see every day, I used to see on a lot of like visually impaired people walk from one place to another, crossing the road. And that's where it's something super interesting, that when you see them cross the road, and in India, what happens is they will not be able to afford something like a guide dog or have an assistant. So they have a really hard life in commuting one place to another. And I learned that because a lot of times they used to ask me to help them cross the road or help them walk them from one place to another. By randomly walking by in the streets, you would meet these people. And what fascinated me was, while everybody was like, all of us, the rest of us rather, we were using Google Maps and we were using GPS-based navigation systems to find directions. These systems were not usable by blind people. And so I went back to my manager and said, why is that? And then say, go and talk to the blind people. And once I spoke to them, that what if you use a phone and get a sense of direction, that how to walk from point A to point B, can't you use that by using audio-based navigation systems? And that's the first time I learned about what is human-computer interaction, how important it is to empathize with the user. And they said that it's the sense of hearing that they use to make sense of the real world, the physical world, through sounds. So if you put like headphones or earphones while they're outdoors, they will not be able to listen to their environment, rather see the environment through their ears. And that kind of made me interested, what are the other senses in the human body that you can exploit in order to give this directional feedback? So very quickly, I put together a prototype. I'm sure a lot of you have heard of like Arduino. One second, I'll just show it to you. So I went back to my lab, picked up like very low cost parts from the market, and built. This is what the finished product actually looks like. But I'll show you the first napkin sketch version of it. Yes, so here it is. So I picked up $4 each, or less than $1 each actually, these little vibrational motors, and put them inside a shoe. One for north, this is for south, this is for east and west. And essentially, can you communicate and condense the geo-navigational information into a shoe to help the blind people navigate? So I quickly built a prototype, which of course it used to look like a very scary prototype with wires coming out of the shoe. And and I would show it to visually impaired people, and they would be like, "Huh, this is interesting. Can we try it?" And once they would try it, I realized there are so many problems with it, which is they're not able to localize the vibration in that exact point. So through that, what I realized was, okay, we need to make the prototype better, need to iterate it. And I started hanging around with more blind communities around the country to show what I had done. And what I learned was that this is not just an engineering project. This is a circuit. This is a design of a shoe that can vibrate and tell you the direction. But this is also about human aesthetics. And now that you're building a shoe, you have to think about shoe design. You have to think about aesthetics, because nobody is going to make a shoe that has wires coming out of it. So I started making friends with people who come from backgrounds such as design, people who come from backgrounds such as industrial design, ergonomics, to learn what it takes to design an electronic system that can be put on a human body. Couple years passed. I left my job, met somebody who one of the blind people introduced me to, and eventually started a company. This, like, it started solo, but 1.5 years later, this was the team. This was my co-founder at that time, who also quit his job, moved back from the US to India. I used to be young back then. And we put together a team like this of people from variety of disciplines. So people who know about electronics, engineering, science, ergonomics, shoe design, manufacturing. And a few years later, what we had was a aesthetic looking product that we put out in the market that thousands of people started eventually using. During this time, my biggest learning, I would say, if I look back at it, was how important it is to be able to build teams with people who come from disciplines that are very unlike yours. So for example, if you are good at science, you should probably make friends with somebody who's good at business, or somebody who understands economics or the user psychology a little better than you do. And the same for vice versa. Like, having good ideas is just not enough, but so you need to combine with engineering, and just being a good engineer is not enough if you're not solving good problems. And this, like, through this project, I was very fortunate to go and meet like visually impaired people around the world. So we would be, and one of the people that we met was a professor at MIT, and I was very young then, like 22, and I had a conversation. I want to continue exploring how computers and information and AI interacts with the human body. What do I do next? So I went on to that's where I met Alicia. I went to the media lab at MIT, where the company kept running. I went to the media lab to explore what is doing good research like. I came from a very average engineering school in India, and it was really big deal for me to be able to get a scholarship to go to MIT, and that's where I met amazing people from variety of disciplines, unlike me. So I came from a computer engineering background with a background in electronics, but the next person I would sit to would be somebody who has been in Hollywood and made movies, and somebody who would be a computational photographer, people who would come from neuroscience background. So that was very fascinating and exploratory field. So I went on to explore the creative side at that time. Augmented reality, like using artificial intelligence to be able, and augmented reality to be able to do things, it's still a very popular field. And when you talk about augmented reality, you think about like these headsets that you wear, right? Like these Google Glass and these systems that you have on your headset, like Oculus and so on. My professor's view was that, how do you instead of like making people wear new things like glasses, how do you bring augmented reality to the physical world by using objects that people already use? So if you see in this company, we used a shoe and augmented the shoe with a new technology. And so at MIT, I picked up this project where we where we picked up a ruler, the regular ruler that you use to draw and measure things. How would a ruler look like in future if it was it was modified with augmented reality capability? So this is a demo video. So you keep drawing with it the way you would draw things on paper. Uh, and once you're done drawing, you would how do you show interactions to people, interactive interactions, just in time at the right. So, like this is like a physics example that you draw like a free body diagram. Now you can see the ball's simulation right on the paper itself. That how would it animate in the physical world? So such projects were like a combination of there's an engineering component to it, there's a design component to it. There are very small, tiny AI models running. Everybody knows about AI right now, ChatGPT. These are tiny AI models that recognize gestures. So when you're drawing something, that's all being recorded. But the idea is, how do you make it simple enough that somebody, like very simple, that your grandma can use it? Like, because everybody knows how to use a ruler, basic assumption. So this a set of interactions built on it. So so a series of experiments like this was the end of my thesis. And that's something very interesting that happened, of course, at MIT. I made friends with a lot of people from different disciplines, right? Not just computer science and AI. At that time, during that time, I used to travel back and forth to India a lot. And if you remember, I don't know if you noticed it. I'm right now in Delhi. It's one of the most polluted cities in the world. Polluted as in there's just so many people and there's so many vehicles. And there are 5 months of the year that the air quality index is above 700 to 800. If you measure it, sometimes it's beyond the reading that your sensors can actually measure. So I would travel back to India and I would notice that it was a very funny observation that how quickly my shirts would get dirtier faster. Like I'm wearing a white t-shirt and it'll start looking yellow by the end of the day. And if I don't change it, which would happen a lot of times during college, for a couple of days, they're probably like turning blackish and the collars turn completely black. My mom used to find it really gross. But if you think about it, what makes it dirty is actually the pollution. And if you think about the pollution, what is it? It's basically unburned carbon in the atmosphere that you're all breathing in. And that's the thing that is staining your shirt. Back and forth, meeting friends. Back at MIT, one of these friends of mine, he was a material scientist, and he said, Anirudh, what if you start looking at carbon as a source of something that you can print from? If it's making your shirt dirty, it also has an ability to leave an impression on paper. It was super interesting because, so again, like I did before, I spent a weekend with this friend and started building a printer that could actually suck in these particles from the atmosphere and print from it. So this was a very, very early experiment. Because it was done in a room, I had to use a candle. So here is, you've all seen this, right? And the interesting thing is, whenever you will see fossil fuel burn anywhere, like whether it's your car, chimney, anything you'll burn, you will produce this material. And that's what flows in the atmosphere. So this printer that we designed sucks in this candle soot through electrostatic precipitation and mixes it with some vegetable oil and some vodka, just as like very easy to use chemicals. And then you pump it into a printing cartridge, and essentially you are able to leave impressions on paper, and you can print with it. So here, like I'm able to do like art. I can also print text with it, just like with a regular ring. These prototypes this is like rapid prototyping. So these systems don't work after more than like a few times. They're very, very rough, quickly built. But I was lucky enough to record this on video. And At that time, when I built this, the pollution problem in India became so big that people started taking note of this project and said that, hey, what if we start to do this at a scale? And that time, this was crazy because I was sitting back in Boston, but in India and most developing countries in the world, it's a huge problem. So I thought, I'm still young. Maybe we should give it a shot. So me and my friend, we were convinced by a couple of mentors of mine that maybe we should go and take a stab at this problem. So we did. Couple years later, we modified this contraption into. I'll show you what it looks like. Link. Into a system that now is used on chimneys and small diesel generators later to be able to capture pollution at a large scale. So essentially put this on your exhaust. It doesn't look like this anymore. These are early experiments. How do you actually capture pollution at the source and turn it into useful pigments and materials? After like a few tests, this is what like a capture pollution looks like. Like these are different samples captured from a diesel generator that is 4 years old versus a car. They all look the same, but the chemical composition is slightly different. And this is unburnt carbon. And if you notice, it's very interesting that carbon is the building block of every black color that you see out there in your plastics, in your phone, in your inks. It is actually it's made by deliberately burning fossil fuels somewhere. So we thought like, what is the point of burning fossil fuels when you can, just capture this carbon and make a product out of it? This narrative was picked up by the printing industry, because all artists use inks, right? And they were like, and inks are really toxic. They thought, what if the ink could have more powerful media and a story and sustainability when it comes from a source that is completely unwanted? Like we were turning like pollution. So what we did was we industrialized the process a few years later and turned it into air ink that is used in different industries around the world. A small group of artists use art material like this, which really helps in spreading us the message. Because when you give it to artists, what happens is they do wonderful things with it. So if you Google air ink, you will see hundreds of like murals by some really popular artists. Like this is like a thing that was put up in London at the Piccadilly Circus. This art is painted by air pollution. All the black color is the color that we captured in Delhi skies. So we started getting into the business of selling pollution upcycled and turning that into product. After artists started adopting it, a lot of big industries started seeing potential of it. And it became like we started talking to companies like Dell and Hewlett and HP who were into like industrialized inks. In a few months, we started seeing companies like very big companies like credit card companies like MasterCard. You probably used MasterCard, right? Like credit card. So if you see, it says that this card is made of biosourced material and printed with air ink, recycled carbon emissions. So it became a label that got recognized, and it became a legitimate business, which after people seeing it on MasterCard and top artists using, other bigger companies started approaching us. So the money we would make on printing for these large brands, we would use that to basically capture more and more pollution at the inlet. So essentially turning pollution into highly profitable product. And there's just so much of it that probably like thousands of businesses like us can exist out there. So this was the journey with air ink. I just wanted to show a couple more examples. If you've heard of Naomi Campbell, she's this really famous supermodel who now makes clothing with air ink. And they have, and what this did was we spent zero money on like actually working with these artists. These artists themselves had a huge sustainability focus, and by using our product, they would look more sustainable to their audience. what this did was it strengthened our brand and presence globally, and then the money that would come from these things was used to scale up pollution capture pilots. So in a period of from the period that I showed you, that printer, from this to something like this, it took us 5 years. And again, this happened because of collaborating with people from disciplines completely different from us. Because of this, we got to when our work day used to be starting by doing science in the lab. In the midday, we would be doing operations, and by the evening, we would be talking to artists and celebrities who would be launching their products by using air ink around the world. Um, any questions, Alicia? Like right now, to interject?
Does
Because
anybody
I'm
have
not
any
looking at the screen
questions?
at all.
No, not so far. But I think I had mentioned when somebody was registering, they were asking about what's the model for, because these inks are packaged into the pens and the things. Are those sustainable or recycled as well?
We try to be as sustainable as we can. We don't ink is never the final product. If you see, ink is a commodity. Like people buy pens, people buy fabrics that are made from inks and so on. So we don't sell ink mostly to consumers. Ink goes to industries that do printing with it. There's a very small segment of consumers that we work with, who mostly is primarily for awareness purposes, is the artists. So all artists have to use some kind of a marker. And so we made this very difficult choice that what kind of marker should we use? There is nothing else in the world that you can use to make a marker that is scalable except plastic. So you have to use plastic. Although we try to put it in a plastic that is reusable. So these are the markers that we use are refillable. So essentially, once you buy it, you don't need to keep buying again and again. You can just open it and refill it. But if you see most markers that you ever would buy in the market, you would just use them and throw them. So these are small changes that need to happen in the industry as it evolves. The ink that goes to industries, for example, that is not packaged in plastic. That's shipped bulk in containers around the world. We are not that big a company as Gravity that we have operations in different countries. So right now, whatever is happening out of 2 locations in India. But most of our users, which is big companies, are in European and American geographies that have the propensity to pay for the sustainability markup. Yeah.
Anybody in Canada or not
Does
yet? No, I'm asking
Sorry?
anybody in Canada, anyone in Canada who's using the product?
I mean, I am not I'm not directly involved in the business side of it anymore. Like 1.5 years ago, I exited the company, but it's still active. I'm very well connected to the team. In Vancouver, there was a very big TED event, and that's where they did a huge mural at the at one of the centers. Even in Toronto, like at BCG Center in Toronto, there's a very big mural made out of air ink. The most production, even if you see most American companies, their production is in China. So essentially, even when we work with Dell and even when we work with other bigger companies, the production will happen in Asia, like China, Vietnam, India, or Mexico. That's where all the production centers of the world are. That's right. So does it answer the question?
Kind of. And Roxanne has a question asking, can pollution ink come in different colors?
So the very, very interesting fact is, this is a good point. We have a very strong identity in black color because we can only make black color from capturing the kind of carbon we were capturing, which is essentially black in color. If you look at it, there are so many other ways that you can use biology, that you can use other forms of bacteria to make inks. So there are a lot of interesting companies that, if you Google like bio-based inks that are made by bacteria, so you can feed the bacteria on a kind of on, for example, CO2, and that can ferment CO2 into some sort of a precursor for a different color. This specific technique is only carbon-based black color. I'm talking about inks because that is very simple to understand. We also later went on and became fillers in plastics. If you go inside your car, all the dashboard of your car is black in color. And it's not just color, it's basically carbon fused into plastic that makes that material. So we also started working closely with plastic industries to replace the carbon that they would use conventionally and replace that with the carbon that we would capture from our sources. So yes, we are limited by we make all shades of black. Is what.
But I think
say. Yes.
Yeah, and shades itself, as you mentioned, if we combine it with other sustainable pigment sources, that creates different colors. Like if you look at it, just like as you mentioned, shades, mauve, like they all use some element of black. So I imagine like it can be combined with
Absolutely.
Other. I have a question again that was when people were registering. What is that device that captures the carbon?
Sure. So carbon capture is a very like I don't come from actual carbon capture technical background, but I have dabbled a lot in it, like built an entire team around it. There are two forms of carbon. One is the gas, the one that you don't see, which is CO2, which causes climate change. It's a greenhouse gas. And the second is the carbon that is most harmful, which is the solid carbon. And it's harmful because it goes directly into your bloodstream because you inhale it. And it's virtually everywhere. Whenever you will run a car, you will have it. You will run a generator, you will have it. Your ships, your planes, they all produce it. So the carbon, these are just particles, very tiny particles, 1/70th the width of human hair, like 2 microns in size, 1 micron in size. The principle that you use in very simple language is like when you take a comb and you do electrostatic charging, you can pull paper with it like a magnet. The same way, if you produce electrostatic charge, you can catch carbon without exerting any back pressure on the exhaust stream. So by using charges, I mean, if you ask, you can just use like a filter, right? Like a HEPA filter think about like a piece of foam. If you put it next to an exhaust, you can also capture carbon with it. The reason why we use electrostatics is because that piece of foam or that filter or that handkerchief, it'll get clogged eventually. So what you want to use is something that is a filterless media, like something that does not will not get clogged, and it can keep capturing without blocking the airstream, if that makes sense.
That's quite amazing. And again, just the idea that you started by just noticing what is in your environment, and that observation over time led you to come up with something absolutely brilliant. And that's very inspiring. I wonder if audience member have some other question about either this project or any of the other projects Anirudh shared, or just anything in general. Feel free to unmute yourself, or you can also use the public chat to share.